So why should I deploy my application to Azure Kubernetes Service? Well, one of the things that I really like to tell people is that we have some of the biggest experience in-house around Kubernetes. We're talking about people like Brendan Burns, people who are core contributors to the open source project. They are part of Microsoft, and they are every day working to improve the AKS product so that you, the Kubernetes user, you don't have to worry about building all the underlying infrastructure. You don't have to worry about creating networks, and you certainly shouldn't spend hours and hours, say, dealing with outages. Microsoft has provided you with Azure Kubernetes Service as a way to increase how much work you can do by reducing the overhead and giving you a place to deploy your containers. So whether you're an enterprise, you're a small company, it doesn't really matter. AKS could be exactly what you need for your application. And we have the experience to help you not only deploy it, but to scale it and to grow with your application. So give Azure Kubernetes Service a try if you're ready for Kubernetes, but just don't want to do all that extra work.
Hey, Zach.
Hey, how are you doing, Jay?
I'm good, man. Welcome back. Hey, everybody. Welcome back to AzureFunBytes. And this time, we're going to do a little something different. I think we're always used to me, Jay Gordon, as your host, driving a lot of this. And what have we done? We've driven a lot of things. And Zach, you and I have done a ton lately.
Yeah.
On HashiCorp products, and specifically, we've worked around Terraform a bunch lately. And you helped me with like 2 sessions already. We looked at a bunch of things. We've talked about how AKS or Azure in general is able to connect. We've talked about things like its integration with VS Code. And so all these really useful ways of integrating different products to handle things like infrastructure as code and such with your Azure experience. So all these third-party products, they come together. And so what we're talking about is a combo today, right, Zach?
Yeah. So we do have a combo. We're going to go a little bit deeper and talk about some things from Terraform 14, Terraform 15, AKS. We're going to look at Consul, and we're going to do that with some help from our friends over at HashiCorp.
So before they drop in, I want to show everybody for just a few seconds what Consul is, because I think Consul is going to be a nice little tie-in. So let's give this a quick watch, Zach, and then everybody's going to come join us. Sound good?
The core concept of networking within Consul is driven around creating a common service registry where information about the health and location of all of your services can be managed in real time. This information can then be used to drive network automation within your services and other networking hardware by discovering information using Consul's DNS interface or leveraging API integrations with other technologies. Consul works across many different platforms and technologies, allowing you to seamlessly connect workloads across multiple data centers and clouds. For example, services running in Kubernetes can easily discover and communicate with services running on traditional cloud instances or virtual machines. Consul has several native integrations with different platforms for bidirectional synchronization of the service registry catalog. This allows Consul to serve as the bridge between modern and legacy platforms.
Well, that's what we're talking about. And here are the people we're going to be talking about with. We've got some guests. Taylor, if you wouldn't mind unmuting, I'd like to go ahead and have you say hello. Hi, Taylor. How are you?
Doing all right. How about yourselves?
I'm good. And Kareem, thank you so much for joining us as well.
Thank you for having us. It's great to be here.
So we've got a lot of cool stuff to kind of talk about, and looks like you've already got fans. So before we get started and really talking in deep about like the tech, I'd love to hear about you all. And Kareem, why don't you give me a start first? Tell me about who you are, what you do, and how you do it over at HashiCorp.
So I'm a senior developer advocate at HashiCorp. We're focused on the infrastructure line of products, so specifically Terraform, Packer, but obviously our products work well together. There's a nice combo package if you use all of them. We'll talk about that in a bit. So that's pretty much what I do.
And Taylor, I ask you the same question.
So I also work on infrastructure over at HashiCorp. I'm a developer advocate, and I'm also focused on application delivery. So that's things like how do I use waypoints to deploy to my Kubernetes cluster that I spun up with Terraform? How can I use Vault and Consul and all of the other HashiCorp stack to really make everyone's workflows an easier place and a more fun place to be? So really exciting, lots of fun.
Very cool. One of the great things about working in developer relations is that you get an opportunity to get in the weeds. You get to play around with these things. You get to experiment. And then the output of it is once you've gotten yourself pretty dirty and you've figured it out, then you get to go out into the world in situations like this and have conversations and instruct people and really make them appreciate the value of these products and how they work together to make your life simpler. And that's essentially what we're talking about today on Azure. So we kind of started chatting about it a little. And Zach, in the past, we focused more on just a pure form of Terraform without really getting too deep into the weeds. You want to give people just a quick recap on some of the things we've looked at so far?
Yeah, sure. So the last two shows that we did where we were talking about HashiCorp Terraform, we went through some of the basics. We went through what you'd use it for, infrastructure as code as a whole. We talked about providers, resources. We talked about variables. We went a little bit deeper on the second live stream where we talked through using remote state, why that's important. We talked about also how to set environment variables, how to source that file, how to keep your secrets out of your code, basically, and how to use those for. That's pretty much what we went through. Yeah.
Very cool. Yeah. Being able to do things like hide your secrets in Vault or using an Azure service. I know we've got that. It's important because nobody wants their credentials to go out over the wire without any encryption. And we also need to make sure that we're actually able to do things like create service principals, which are very, very important within Azure because we're looking at our IAM kind of situation being more rooted in Azure Active Directory. And I think that brings up a lot of good stuff related to service mesh and things that I believe HashiCorp products do very, very well.
Yeah. So something we didn't go into, and maybe this is a good place to launch things off. So I know Terraform 14, it released somewhat recently-ish. What are some new things that came out in that release that you guys would say are worthy? I know there's concise diff. There's the dependency log file. Can y'all go into some of that? I didn't cover that in our last live stream. Maybe we can kick off there.
I'll go first. Concise diff is definitely one of the cooler features because, especially with resources like a kube cluster, managed or not, you just get so much stuff. And not seeing all the stuff you didn't change, lifesaver. Other favorite feature for me is being able to take state from various versions of Terraform. I'm sure you covered this. When you have multiple Terraform projects, you have multiple state files, you might not be able to or might not want to update all of them to the latest version. So that used to be really hard because if you split them, you did actually have to update them. Now you can just have Terraform 14.5, read a state from 13.6 and go on with that and consume the data from there. Much nicer.
Would you like to talk about this provider dependency lock file? I'd be really curious to hear about that since we know that state is so important with Terraform.
Taylor,
Yeah, you want to take that, Taylor?
Yeah, of course. So with the lock file, it makes it really nice and easy. So when you're using something like Terraform, you want to be able to stand up your infrastructure in a declarative way for one, and then you want that to be repeatable and reliable. Surprises are great for birthdays. They're just not great for infrastructure unless you're trying to, write a blog post or have a good story to tell. With the lock file, that makes it a little bit easier because then you can have that certainty of were these providers signed? What version are they at? You get that, SHA value, and then you're able to kind of pull that in, do a Terraform init, and then, get that extra level of certainty. Before you'd still have that when you would pin your versions, but there was no guarantee that, that label or that tag wasn't force pushed. someone could have modified that and pushed that up, so you didn't really have a guarantee before. The lock file changes that and gives you that extra level of security and certainty that you are using exactly what you want to use.
So let me put this in. Where'd it go? There it is. Would this document kind of be where we're looking is the lock and upgrade provider versions for? No, this is completely different. This is for specific providers regarding like modules within Terraform, right? Because this is another new feature.
Correct. Yeah, I believe that was Terraform 013 that introduced the required providers block that you could provide. So you can, set your Terraform version that you want to run your Terraform modules or your Terraform code, and then with the required providers, you don't have to put those in there. Terraform is smart enough to be able to look through your code and see what providers it needs to download. But if you want to, again, give it that level of certainty, download the Kubernetes 2.x provider. You can put that in the required providers, and then that will also make its way to that lock file.
So we've got a quick question that Zach and I can kind of knock out real quick. I'll answer this, and Zach, if you want to add on to it at all.
Sure.
Someone would like to know, Sem's Life would like to know, what is a service principal? And so we talked about it just a second ago, but a service principal is an identity created for use with applications, hosted services, and automated tools to access Azure resources. A lot of times it's a key pair. Or whatever way you use it to actually connect applications to their authentication, if you will. And so one of the things that I know, Zach, that we do with it is being able to connect things like Kubernetes to other services. You want to give a rundown of how a service principal kind of is part of using Terraform?
Yeah, sure. So the big way that I explain this when I talk to people specifically about Terraform is you can authenticate Terraform using your credentials. You can do that on the command line, but you don't want to give your credentials to other people. There's if you wanted to have people authenticate as the same way that you are authenticating, you create a service principal for that authentication. So you can also authenticate Terraform with a managed service identity or MSI. That's a little bit different. But yeah, a service principal, you're basically creating an application authentication, if you will, and you're able to use that to authenticate based on the roles and the access that you set.
Great. And so that really kind of level sets that question. And our friend Sem's Life says, thanks, no problem. That's why we're here. If you have any other questions, feel free. And also, right now on Learn TV, so if you go to aka.ms, Learn TV, if you're watching on one of the other distribution points, right now I've got a poll. I want to know if you're using Terraform to build your infrastructure resources on Azure. So if you go to this link, which is aka.ms/learntv, you'll see where the poll is, and we'll take a look at it a little later into the show. So I'd love to kind of start taking a look at some of the big ideas you'd like to share with us today. So I'm going to watch y'all, and I'm going to let Zach and you two kind of like discuss what's the big thing you all would like to. So if you need anything from me, I'm going to be here. If you need to share a screen, just let me know.
Awesome.
Cool.
That sounds good.
Yeah. So I know we chatted a little bit about Terraform, about AKS, and a little bit about Consul. What would you guys like to chat about or show today?
I think we've got a little demo that we want to show you where we essentially use Terraform, spin up an AKS cluster. We bring in Consul through Helm, and we want to show you a couple different providers.
Yeah, no, that sounds awesome.
Everything codified, so easy to maintain. We've got a repository for everyone to play along with or, try out later. Got some nice features in there. So
Awesome.
I guess,
is that the code sample link that you've dropped?
So that sample is actually some of the new features that Terraform 014 introduced.
Okay.
Where we highlight some of the coolest features. I mean, there's obviously always more, but these are, I think, Taylor and my favorites.
Gotcha. Do you mind dropping the URL for the code samples if you have them up already? The ones that you're going to work with, that way the viewers can play along or follow along if that's cool.
Absolutely. Give me a second while Taylor gets his editor set up.
No problem. No problem. Jay, when you see that, if you don't mind posting that. Thanks, man.
Awesome. So I'm sure my screen, like Kareem said, today's demo is going to be, we're going to stand up an AKS cluster with Terraform, and then with that cluster, we're actually going to stand up the Consul Helm chart. Now, you might have done this before, but we're doing this a little bit differently. In this example, we're going to be making it a production ready, just about Helm or Consul cluster. So that's going to be, hopefully that's going to help you propel your efforts if that's been something that you're looking for. And just really, really excited to show this to you.
Awesome. Thanks. Oh, and Taylor, you ready to share your screen? Jay, did you? There we go.
Absolutely. Awesome. So it does look a little tiny. I'll scale this up just a bit for you. If you need any more magnification, please let me know. I'll try to kind of get the core essence of what we're trying to cover here in the screen as much as possible.
You're looking great, man. Thank you so much.
Absolutely. All right. So I'm going to start this off. I'm going to kick things off and get this going, and then I'm going to step into the code and kind of walk through each of the components, what we've created today. So first, like any good Terraform user, I'm going to run Terraform init. Just make sure that I have all of my modules and providers and everything that I'm using today, just so that we can actually run these and have that certainty that we're all at the right version. I ran this a little bit earlier, so I shouldn't see too much of a change here. And we've pinned our versions as well, so that also should not change.
And just a quick question. So the reusing previous version from the dependency lock file, is that the release there for 14?
Exactly. We can see that it's reusing that. There's indicating no change, and that nothing has happened to that version. And then we can see here the signed by HashiCorp. We have that certainty that HashiCorp knows what it is and actually signed. It went through the right channels and release process.
Cool.
Which, when you're working with important infrastructure, it's important that it gets run through a provider you can trust.
Oh, for sure. Yeah. And the company creating Terraform signing it is a big deal for sure, to make sure that it is, like you said, something that's verified.
And it's obviously it's all automated. It's not a single person doing it. And we work with our partners like Microsoft, making sure we get the new features out. So the Azure provider actually gets, I'm pretty sure, weekly updates on Thursday. It's super nice because new feature comes out, API support is added, and it's in Terraform pretty quickly.
Yeah, we have a pretty good partnership with HashiCorp, obviously, and like you said, feature parity is really rapid between the two.
I think it's also the only way to get tools like this to keep working, right? If you have to wait a year for it to become available, there's little incentive.
Right, for sure.
It's such a bummer to not pin your dependencies and kind of have that assurance, because if you have something that works on Thursday or Friday, or works an hour ago, and something gets released and then it gets pulled into your plan and your init process, if that doesn't work, that's really frustrating. And nobody likes solving bugs, especially on Fridays. That's typically when those creep about.
Yeah, for sure.
So I've run Terraform validate. That ran through and did a static check of all of my Terraform code, made sure that all of my variables were as they should be. Syntax is good, references are okay. And again, tested this out, so didn't really expect anything to go wrong here. It would have been a fun surprise if that were the case, but everything looks good on that front. We're going to go ahead and run a Terraform plan now. And in this step, just make sure that everything that we're standing up looks as it should. I'm using Terraform Cloud, the free tier, to store my state. That's why you'll see that this is running in a browser here. It made it really easy for me to collaborate with Kareem on this as well, so that I could put my all of my Azure credentials and information in a hidden way into Terraform Cloud, and then we could use the same state. We could plan. We could apply and kind of work in a more collaborative way. So that was really helpful to have. So we're going to create 10 resources here. That looks correct. And then as soon as this is finished, I'm going to go ahead and run an apply.
Cool. And is there anything, I didn't mean to cut you off there. Is there anything that, besides an AKS cluster that you're creating here, that's unique?
I'd
We've got
say
some network resources. We've got an AKS cluster. We use a couple different providers. So, Taylor, if you can scroll up to the init, maybe that would be the easiest way to see it. We've got random string generation to just make sure resources are actually globally unique. You know, like what is it? The storage accounts, for example, need to have a globally unique name. So we want to make sure the first part actually reflects what we want, and the last, I think, 6 or 8 characters, we just use something random. Things like that.
Yeah, and that's actually a good call out there. I don't know if you can find that line of code easily, or lines of code there showing the random, because there are things like you mentioned that require a globally unique identifier, a globally unique name, so that not only in your account but globally, across Azure. And so you would use like Kareem mentioned, a something that's meaningful to you, and then that random identifier at the end. So you make sure that you, as many times as you run this over and over in different environments, you're not going to step on your own toes or someone else's toes.
Yeah, exactly. And it's a powerful feature because at the end of the day, sure, everything we do and build is treated as cattle, but you still have an easier way finding a resource that you know at least 75% of the name, right?
Oh, for sure. Yeah.
And one of the things I like about this, and just sorry to butt in, is that infrastructure as code kind of remains the same concept, regardless of who you're using to provide it. Whether we're using Azure Resource Manager templates or we're using Terraform, the idea here remains the same. Our infrastructure should be in a repository that we're able to use as a source of truth for the things that we need to accomplish. And I think that that's a really big part of this I'd like to remind people of, that these things aren't just about building your resources. It's about making sure that you've codified everything that comes along with them so that modifications can be done in code rather than someone to go into a server, SSH into it, reorchestrate all your containers manually, whatever it is. It doesn't make sense to do that. And so we have the tools. And like I just want to remind everyone, infrastructure as code is, whether, like I said, whether you're using Bicep, whether you're using ARM, whether you're using Terraform, it's all there to provide you with that same big idea that your resources are in a GitHub repository.
Yeah.
And because it's codified, you've got all these beautiful features that versioning gives you. You know, review with your team, run GitHub actions against it, automatically deploy, make sure your code is linted. There's a ton of good stuff there. And it's reliable. It's definitely more reliable than a human at 2 a.m. going like, hey, you know what? I'm going to click here and make sure I spin up the same Linux virtual machine every time. And I
love this comment from Johnny, because it really does bring that whole DevOps ideology into the whole idea. Whereas one of the most important parts of all this is making sure that infrastructure as code is capable of being worked on by more than just one person. That we're so focused on ensuring cross-team usage of our application code or our infrastructure code, whatever you want to call it. And so this just adds to collaboration.
For sure.
I think one thing that Taylor mentioned, you might not notice, based on our latency, but I'm in Amsterdam, Taylor's in LA. So we work in very different time zones. The beauty of having Terraform Cloud in our case in between is he pushes his changes, has his Azure credentials in there, service principal. I don't need to know about it. In fact, I can't know about it because he never sends it to me. But I can still run the code and see what it does. And that's the thing I care about.
Yeah, and that's an important call out to Terraform Cloud. I think we briefly touched on it the first live stream, but it's beautiful, and we need to show it more. If you guys have time today, if there's any way to show that a little bit, that might be beneficial as well. There you go.
Yeah, absolutely. It is really nice because you can mark different variables. So you have environment variables, and you could just use Terraform variables if you wanted. If we wanted to add something new in the variable section, you could make it an HCL map or a list, something like that. And you can also mark it as sensitive. So if for some reason don't do this, you wanted to put your credit card number in, something like that, something of that level of, you know, your service account. All those credentials are really, you don't want that getting, you don't want those in plain text. You have the ability to set that to sensitive and share that with your team without sharing it directly with your team in plain text.
Yeah,
Really
for sure. And just for anybody watching, when you mark that sensitive, it makes it write only. So no one can read that. I believe you can't even read that. Once you set that as sensitive, you can only write over it.
Yeah, it's a write once, and then it's just encrypted and unusable for us, which is how it should be.
Yeah, for sure.
Obviously, credit card number, you'll still have access to it, but in the backend, we just run a vault server. Well, there's a layer of work to it to make sure it does work, but it has to be seamless.
For sure.
And we can even see the runs too. So if I went and forgive me, I had to confirm that run. So now it's actually going about running. This allows, you know, we can see, you know, Kareem ran this, I ran this one. And then this gives us that visibility working together. If something's locked, we can see, oh, well, why is it locked? Is Kareem working on something? I could see, yes, that is the case. And then the feedbacks that you'll get on your console as you're running your Terraform apply or your plans, it'll tell you if things are queued up too, which is, again, just really, really helpful and fantastic. Again, really easy to create a workflow that will grow with you as you start to add more people. Absolutely recommend it. It's a lot of people, you know, I'm the same way when it comes to something like GitHub and paying for anything. I want to pay for something because I want to help that project succeed, but at the same point in time, I want to have a free tier so I could actually get to understand it, right? And really, this is just a tool that helps enable collaboration. That's been the best way that I found to describe it. And it's just it's a really helpful tool when working with Terraform, and it's something I really enjoy doing.
So, something that I honestly I can't remember. So in a workspace in Terraform Cloud, can you set like you just ran that apply? Can you set who can do the applies, who can run the plans, and things of that nature? Is that, I think you can, right? Or is that only enterprise?
There's a teams and governance level, and so you can set up those, you know, how many does it need approvals from these people, this group of, you know, this group, this team. I found some really interesting patterns in the community space where people will kind of combine access control of GitHub, you know, Okta, and just kind of create these really intense workflows but, you know, in some cases they need to. If you're working within, you know, you really want to make sure that information isn't shared out.
Yeah, and that's like, it's super powerful. We call these gates in Azure DevOps, and it might be a similar verbiage here, but you could literally say, I'm going to submit this plan, and the team has to review it, or whoever you set has to review that before it can go through. So it kind of forces that collaboration as well, much in the same way like a PR or a pull request, you know, could have that reviewer process. It's pretty neat to do that. Like, it's like one step further into the actual Terraform run. So that's pretty cool.
And you know how it is every time you build infrastructure with your team where everyone understands what you're building and what you're deploying.
Right. Yeah.
Maintenance gets easier, right?
Yeah. Yeah. It's collaboration. Like, I keep going back to that word, but it's just beautiful collaboration for infrastructure as code. And I love it. I love it.
It's nice.
Quick question, Taylor. I'm sorry. These two screens, these are one VS Code showing the build. So do you have two separate builds going on at the same time?
Great question. So what this is this apply is actually happening in the cloud. This is using a Terraform Cloud Runner. And so what I see in my shell is exactly what is actually running. So this is just streaming that log output, you know, in a UI on the web, which is really helpful if you just wanted to kind of, what's my team working on? You wanted to go see what's going on. You could do so there. And if you're the person actually running that, you know, plan or apply, you can actually see it within your shell as well. So these are actually both the same output, just surfacing from this run that's happening right here.
So do you want to answer this question we have up right now, which is what actually triggered the run?
So what triggered the run was me, I think, all the way up here. So I ran Terraform apply. You can, that is another thing that's actually worth getting into, is that, let me expand this out. If I wanted to go in here and change the actual workflow, so this can respect a GitOps workflow. There's a whole bunch of different execution modes that you have available to you. Right now I'm just using remote, so I can actually use, when you run things remote, you have to set all those variables. It's not going to source your environment variables on your machine or anything like that. You can use agents if you're using a paid account at that Teams and governance level. You are running on on-premise or edge hardware. You can just use agents, and then that will actually run on your infrastructure. You could run it locally and just use Terraform Cloud for just state alone. Works very much like if it were actually on your machine. It will run off of your machine and source your environment variables there. And then there's the ability to auto apply, which we don't have on right now just because we want to, Kareem and I want that sign off on our code as we're working through this and testing things out. We can set the Terraform version, working directory, or changes to kind of follow a GitOps principle and workflow. Give it a repository. As changes come into the main branch there, then run all of that infrastructure and get that stood up.
So we have another question here from Jotmanodi08. What are some recommendations you have around managing and injecting the Azure credentials that Terraform or Terraform Cloud uses? And I think that you could probably knock Vault right off the top of it and just say that's an obvious answer. Azure also provides secret locking up as well, like our own key vault type of service. Are both capable of being used in this case?
Absolutely. So Terraform Cloud does have its own set of APIs, so you can interact with it. You could link that together through something that better suits your workflow. If you wanted to, if you say you have OpenID Connect backed service, you're using Okta, Auth0, anything of that sort, you could tie that in and kind of source, generate, get those credentials, and then push them via Terraform Cloud's API. That's an option. You could use Vault and some other things too. It typically, obviously, biased working at HashiCorp, but typically we'll go the Vault route and try to get that injected or get a one-time passcode or just a credential that has a specific TTL that will kind of align with what we're trying to go for.
It comes down to what is it that you actually need to protect and how much do you need to protect. If it's just for credentials, obviously for service credentials, use the thing that's easiest for you and that fits with your team. As your usage grows, you might go like, hey, you know what? We need to encrypt files. We need to make sure we have secrets in there that are automatically rotated. This is always the beautiful technical question where it really comes down to it depends. What's your organization ready for? And I think both of them super valid answers and good solutions.
For sure. So it looks like your reply finished.
It finished. I'm going to step through the code just really quick. I'll just go over at a very high level. If anyone wants to jump into any of these pieces of code, we're going to share out the repository so you can take a look at it there. Or if you have any questions about these specific files, anything like that, I'm more than happy to go over. But we've essentially stood up an AKS cluster.
Maybe you want to start with a Terraform TF file. Start from the basics up. So what you can see here is we required the latest version of Terraform. This could have been any other 0.14 version because we don't have anything specific to 14.05. But what's important to us is that when you use this 6 months from now, it should still be that version that we tested it with, not anything later, because that way we can ensure that it's still stable. And the same story holds true for every line where you see a version statement. We're just using what we tested, what makes sense. Some of those don't necessarily need like the 3.0 version of the null provider, but we want to make sure you don't get outdated code from the get-go, right? And that's pretty much it. At the bottom, quick call out to the remote state that we have in Terraform Cloud and Taylor's organization only Dole. And in there, we have a specific workspace that Taylor showed earlier.
So with that, we can also see that we aren't, there are different ways for like greater than, equal to, we can kind of call those things out. But like Kareem said, we don't get that level of certainty if we don't pin it directly. This gives us the most certainty that we can actually use this code again at some point in time in the future. We're giving our future selves a much easier time.
Awesome.
If you want to take a look at the log or the lock file, I'm more than happy to kind of present that here. This is just going to give you those hashes and again that level of certainty that we're pulling down exactly what we expect to use. And then
Essentially, if you've ever done anything with npm or any other package manager that has log files, it's all the same principle. Ours has a little bit of a different layout, but at the end of the day, it comes down to the same function. Stability.
The first module that we typically we'll need to set up the network module first, which I'll get to in a second. But this is just the first module that we're actually using that I'm showing in this example is the AKS module, which is provided by Azure. I was really happy to get a PR accepted into this to specify the Kubernetes and orchestrator versions as they come out. Those are Kubernetes releases 3-4 times a year, and so it's nice to keep that up to date and make sure that those versions are what you're looking for. So we set this up here. Nothing too out of the ordinary. We're using our resource group name, which we've set elsewhere. We're spinning up 3 machines. And with 100 gigabytes, we could create these as Terraform variables if we wanted to, but as you can see, this depends on our network module, which we'll get to here in just a second. The Azure provider, this one's really simple. We don't have to set anything in here because we're supplying those environment variables.
So I do have a random quick question. So the depends on, that was kind of new, right? Was that 13, if I remember correctly?
Memory.
Yeah.
Yes.
So what, Terraform builds a dependency graph. It does things in order and parallel where it can. This may be a weird question, but why the depends on? Does that forces the, it kind of forces the direction, but Terraform kind of had that built in before, right? So do you have any interesting info around why adding that?
So this is actually a super beautiful question because yes, Terraform does look at your whole code base and understands, okay, so you want to have a cluster, which depends on your network, which depends on your resource group. So I'm going to do resource group first, right? Mm-hmm. Sometimes you need to specify the dependency explicitly when a module relies on it. And there's some behavior attached to it that isn't immediately clear.
Okay.
Or you need to get data downstream where it's just a little bit clearer. Will it slow down Terraform? Not really. Is it nice for humans maintaining the code? Definitely.
Yeah. I thought, and this, I never really brought it up to anybody, but I thought that it might be if you're doing something that does need to happen in order, but you're not using syntax interpolation, that might like muddy the scenario. But I never asked it. I figured I'd ask now because I just remembered it in my brain there.
Yeah, you'll actually see when you look at the code that we built for you all today, we've got comments galore in there to make sure any feature that you look up, there's a link you can click. It's also how we like to code to make sure, down the road when somebody asks like, hey, why is there depends on in here? Well, let me go to the official documentation. It's just easily linked.
Yeah, no, that's awesome too. Anytime that I'm writing code, I comment everywhere. It's just kind of ingrained in me now. Not only is the Terraform its own type of documentation, but understanding the thought process, of the person that wrote that code is helpful as well.
Yeah, exactly.
And that's a great call out too, because we do have this module network defined here to pull it in, but it's in some edge cases and in different providers, you might run into some strange race conditions at certain points in time, just based on running things in an asynchronous way. Adding that depends on is kind of like, it's just another pin your providers type of consideration. If you don't call it out, you don't have to put depends on everything. Especially if you've called that out within your variable interpolation within supplying those values to your module. But it really does help, especially when it's AKS. This module only needs the network, so it doesn't hurt to add that there and ensure that that's actually going to be spun up first.
For sure.
I'll actually so we walked through the Azure provider. I'm actually gonna just jump to. I'm gonna skip around here a little bit. We spin up our
The
network.
one thing I wanted to ask you to do is, would you mind actually showing would you show some of the resources actually in Azure? You mind just like bringing up your portal for a second, just show everybody what you've done you showed everybody what you've done here on the in the terminal. I'd love them to see actually in the portal the work that you've accomplished so far and the things you're going to do next.
Yeah, absolutely. Let me get signed in, and we should be. Okay, I'll sign in here.
And thanks to everybody who's in the chat who've been asking questions and taking part. We've got about another 20 minutes with Taylor and Kareem. So, and of course, Zach, who knows a ton about the Azure side and a lot about Terraform and the different HashiCorp products. So if you have any more questions before we finish up, like I said, 20 more minutes, please feel free to ask. I'm going to let Taylor kind of take over now.
Yeah, definitely. All kinds of questions are in scope for us. Best practices, bad practices. We also build a lot of those just to make sure we don't build them when it matters. So ask us your questions.
That's awesome. I mean, not a lot of people talk about like, things other than best practices, but it's good to mention those too. Yeah.
I like if you have an attitude of there are no mistakes, just lessons learned. I feel like it's a good way to get through some tough situations.
Yeah.
So we can see we've stood up a network space. We've stood up node pools. We have one node pool, but there are 3 nodes inside of that node pool. And then we stood up this AKS cluster. So this is kind of the visual representation of what we've actually stood up. Within here, we've stood up a Consul cluster, and we've really given it a lot of information such that it can kind of run in a production-ready way. I think the only thing missing from that is that we have not, and that's going to be inside of this specification here. We haven't, this Consul gossip encryption key is something that we could have created in Vault. We could have spun up Vault first, bootstrapped it in Azure, and then used that to kind of kick things off. But again, this is a demo and just really wanted to illustrate how you could actually get this set up for production. So we can see we've turned on TLS, auto encrypt. We're managing ACLs. We're letting Kubernetes do that. And then we had to manually supply the secret, which I'll show you in a second. We've turned on connect inject, which is going to enable our service mesh, and then the controller, which is going to handle leader elections and things of that nature.
So I don't mean to cut you off again, Taylor. I did want to mention one thing that's super cool and super important. And we covered this a little bit, Jay, in the last live stream, but what you just went through, you stood up a Kubernetes cluster, an AKS cluster in Azure, and then you use the Kubernetes provider to deploy into that cluster, all in the same code base, all in the same apply, right?
We did, and I think that's a beautiful thing here.
Yeah, and it's the same code base, and it's even if you're using a completely different cloud or completely different infrastructure, it's the same commands. It's Terraform init, Terraform plan, Terraform apply. But yeah, and I've showed demos before about building that AKS cluster, deploying into it all in the same code base, and it's a powerful thing. I mean, you're able to call as many providers as you need to in that code base, all in that same run. It's pretty cool.
So you all ready to take a few questions before we move on to the next part?
Let's do it.
Because we actually have a few, which is really cool. So our first question is, I know you're using Kubernetes with this. Would I be able to use HashiCorp Nomad to do this? I've been toying around with the idea of putting Nomad on my Pi.
I mean, the Pi is perfectly suited for that. You can also run it in production. Might even be nicer for services like Consul. The long and short answer is yes, you could.
Okay, very, very cool. Let's get our next question. And it comes from Johnny. And Johnny wants to know, what's your approach to testing the Terraform files? I guess he means the plans. Like unit testing as you would other code?
That's a great question. Honestly, I'd say taking advantage of, there's one piece of code that Kareem added, which I thought was just really, really helpful, was typically when we work through different projects, we'd like to give it a project name or a prefix. It's something to help us identify what it is. It's kind of something that we can use globally. And so Kareem set this validation up such that this has to be, greater than 4 and less than 32 characters. So that's a fantastic way to kind of, these are ways in which you can add validation right into your code base through these variables. You can also kind of validate things that are coming out of other variables. And, if you wanted to say, make sure that it's only one of these instances of compute, this version. You could do that here as well. I do have there's a fantastic talk by one of my coworkers, Rosemary Wong, and she kind of goes through how you would run unit tests, contract tests, and all of these other various tests on Terraform. I'll source that. I think it was O'Reilly conference back in the before times when we were all out and going to conferences and such. But
so speaking of her, it looks like we also have another question for her from her, I should say. Let's bring her up, and here it says, "What are Consul ACLs?"
So Consul ACLs are access control lists. That's going to be how we actually gate interaction with Consul. So when we can create, if you Consul works on paths, and so if we set up a team and we want to give them access to team/app, we would create an ACL for that, and we allow them the ability to read or write or whatever makes sense for that team. So that's a really good way to kind of gate that interaction. And then if we don't want other teams to see that at all, we have the ability to set that and to do that.
Yeah, I think testing is never a simple or single answer. It's always so many different things coming back to that. And especially when you're talking about bringing in secrets, those two always go hand in hand, right? You want your testing tools to be able to access the various layers of the infrastructure you're building. But now you have a problem that not only does the engineer need to know about the secret, not only does the runner need to know, the deployment runner, but also your testing framework. And it gets tricky quickly. It's always layers, many layers.
Very cool. Thanks for answering the questions, Taylor. We've got about a good 15 minutes, a little less than 15 minutes. So if you want to kind of take a further spin into what you're doing, please do.
Absolutely. So we've spun everything up, and I'd love to show you what we actually have running here. So I'm going to go and open up my terminal. We can see that we've output this command, this AZ AKS get credentials. Instead of having Terraform output our cube configuration, we can actually just run this command. Clear that out.
And for people who not really sure, that AZ AKS get credentials is a Azure Cloud Shell command. Specifically, that AZ binary is something that you can run, and it's pretty much cross-platform. You can find AZ for almost any major platform that's out there. Your Mac, your Windows, on Azure Cloud Shell already. It's a really useful tool, and it's how you'll be able to get your credentials at any time. Once you're authenticated, which is just AZ, create, or I should say AZ login, you'll be able to kind of do all these things and get your credentials and then start using kubectl.
And one of the things that Taylor just showed is the Terraform output. If you can go back to that, we're using variable replacement. And as we were testing this, I was doing some search and replace, completely aware of what we're doing, and apparently replaced it with not the correct string. Despite knowing the code base, I messed up, and it happens. So then Taylor runs this command, and if you can show the error again, I think the resource group wasn't found or the cluster wasn't found. One of the two.
I think it was cluster. It has a suffix of -AKS, so absolutely something that we messed up.
Exactly.
Yeah, and that's just to kind of spin off of this on the outputs. This is a custom output that you guys created to be able to easily pull that context for this AKS cluster. And I've worked a lot with Mishra in the past, and he actually showed me full output blocks to basically copy and paste and just do everything that you want to show in your demo really quickly. And it's really beautiful. Based on what you need, you can output whatever. It can be outputs from your resources and your providers, or outputs that are custom that just help you with little hints and tips.
It's so powerful. I mean, especially with this one, Taylor, if you open outputs TF, we've got a couple of them in there, including links to more fun ones that you can open. So the pre-filled kubectl command is simple. At the top, we fill in the Azure resource group name. So if you change your Terraform code, you don't have to go in and change your snippet here. It will just automatically update for you. Now, if you scroll down, sometimes you need to debug a little more, right? So you might need the full kube config. So lines 11 through 14, uncomment those, run a Terraform apply, and your output will now have the actual kube config in there. And you can use it from there. You could even use the file module, file functions, to make sure this stuff actually ends up on your file system. It would include some credentials, so you might want to check with your organization if that makes sense for you. Doesn't always. But if you need to debug, that's one way of doing it.
Yeah, it's super powerful. It's something, outputs are something that I used, but not as much as I do now. Like once I started using them for more interesting things, it's super handy, super handy.
Even and honestly, I've seen some really off the wall use cases of it where it's been people have provided links to run books and things like that. It doesn't even have to be the Terraform values that you have. You could be, if it's broken, click this. If it's not so fun code base to work on, for example. Yeah. But you can enhance that and make that better with Terraform variables if you can source them in any capacity.
So we've got a question up here, and I'd love it if you can give it an answer because I think it's in context. Could I use a provisioner instead?
That's actually an interesting one because in general, providers do all the traditional resources. Most of the time, we'd think about cloud resources like Azure or something in Kube, but it could also be user accounts, monitoring, whatever. Provisioners you usually use for doing things on the resources. You might need to, the way we normally refer to shell out into something, you might need to run a bash script. Could you use that? Absolutely. These days, I prefer sticking as close as possible to Terraform because that's the easiest way for me to make sure my code is nicely documented. And provisioners are generally considered a last resort. So yes, but the but is just don't do it.
Yeah, and I think one of the provisioners for like Microsoft Azure, just to give an example, is like a custom data kind of cloud init situation. So Terraform is actually the resource is providing or standing up the VM, but the custom data does something on it as the provisioner.
It's just like a standard cloud init if you've ever used it with any sort of Ubuntu server, where we've built it actually into the startup part of Linux servers, where you can just toss in a cloud init. So if you're working with VMs, that's like one of the easiest ways to kind of bootstrap your nodes, if you will. I'm not too sure about how that works on containers, but I'm sure that's just part of how you build a container is to have that. You don't need an agent, I would imagine, unless you're using something like Consul on the endpoint, right?
I think as long as you're supporting Cloud Init, then you should be good. But even for that, you could use Terraform as a provider for that has a Cloud Init data source.
That's great.
You can bring it all together. We should get a link up here for the Terraform registry. We're at, I think, Taylor's 700-ish providers right now.
I think so. It's wild. Every time I give a talk, I've got to update that slide where it's the custom providers, default providers, verified providers. Pretty wild. It's really
and of course, we've got them all here. Here's our Azure provider specifically.
You can use the top search bar now. I've really liked the changes that the team has made to the registry page because you can start typing in things in the top search bar, and then you get not only providers, but you get modules as well. And so it'll do fuzzy search, and you can kind of get a sense of what things are. If you click into provider like this, you can click into documentation and then further search on what resources, data sources that you have there, which is quite
and of course, we're lucky enough that we have all of the code with examples and stuff like that within actual like repositories. So we still get that strength of working with code.
Yeah.
All right. So we got about 5 minutes or so left. I want to use those next 5 minutes kind of closing the everything up. So how's teardown look here?
Teardown's pretty easy. Teardown is just Terraform destroy. Before I do that really quick, I'll just show you that that one Consul cluster that we've spun up. and show you that view really quick. So we'll want to use HTTPS because this is, production ready. If you were to make it a little bit more production ready, you would just want to put in, you wouldn't want to use localhost, obviously. I'm doing a port forward in the background. That's why it's going to say, hey, this doesn't look correct. This looks unsafe. That's okay for this use case. And here we can see that, actually I logged in from another session. So we can see consoles here. We can see all of the nodes that we've got this spun up on, which one is the leader at the current point in time. Key value, which, fun trivia fact, this was added in just before Consul went live. It was not one of the original considerations for Consul. Those ACLs that we talked about, we can't log in though, and that's because Kubernetes has bootstrapped that for us really quick. We can actually pull that right out of the secrets that we created with Terraform. I can run a decode here and actually get that value because this isn't stored in Vault, proving that maybe that is a good thing to check out, or your local or your favorite cloud's secret provider. So now after we've logged in, we can actually see, here's the bootstrap token. We actually have access to do this and mess with intentions if we worked with service mesh. But really, that's it. This is we've done everything with Terraform, and it's nice to have that available to us because now we can, if we need to inject this anywhere else, into any of our infrastructure or do service discovery, we can do that. So,
very cool. You want to do that teardown?
Oh, of course. I think it is.
My favorite part is destroying stuff after we put it together. Especially with demos, I just love that part. Makes you feel like you've really accomplished everything.
Absolutely.
I also like to make sure that people who see this see that build-up process should be just as simple as the teardown. And I believe that goes for nearly any one of these types of services. I really do believe in simplicity for users. And speaking of simplicity, I want to just say, you all made this look so easy. Y'all made it look so simple. But I know it's complex, and I know this is a lot to do. And people, take on these things because they want to learn more. They want to get more out of it. They want to build. And so that's what we did. We showed each other how to start building. We talked a little bit how to secure things. We talked a little bit how that networking works underneath using Consul. And, I think we've kind of brought it all together. So I want everybody to kind of Taylor, why don't you give us a little, that's your Twitter, obviously. But why don't you give me any other places we can find you?
So honestly, Only Dole is really the moniker I use across the internet. But if you, two things about me, I'm really passionate about reading. So if you do have any Goodreads recommendations, you want to help me have some interesting books to read while I close out that goal for 2021, I'd love to hear that. I also work on the Kubernetes project in SIG release and in SIG docs. So that's the release process itself, and then documentation for the site, Kubernetes IO, blog posts. I'd be more than happy to answer questions on those fronts too. So please at me. Don't not at me. Please at me. I'd love to talk with you.
Very cool. Kareem, give me a little rundown for you. What can we see you're up to lately aside from your little Twitter handle right there?
Yeah, I think same as Taylor. I like to keep my life simple. Add case utility pretty much everywhere. So if you use any of my Terraform modules and you don't like them, let me know. I'm happy to fix them. We're all here to learn together, right? And so I think for me, what I'm currently up to is mostly making sure people understand why Terraform works and hopefully feel the same joy that I have when we build stuff. It's not always boring infrastructure, like the stuff you do for your company. A lot of times it's just the exploratory testing where it's like, hey, let's build something cool where it makes sense. Let's make life simpler.
Exactly. Well, you two, thank you so much. We're going to say goodbye. Zach, you were an amazing guest host.
Thanks, man.
Thank you so much for doing this with me. Zach, of course, Zipteptawa on Twitter, GitHub, all those places we're going to be able to find you, as well as on the Azure DevOps blog, which all of our team are working on. So as we round down to our last few seconds, let's go ahead and give everybody a big goodbye. Thanks everybody for watching. All of our people who commented today. Thank you so much for being part of this show. We had a great time today. Really, really enjoyed it. We'll catch you. I hope you all come back the next time you want to show off something, because I'd love to see it. So until then, thanks a lot, everybody. We'll catch you all next time. Same time, 2 o'clock on the East, 11 on the West, here for Azure Fun Bites. Take care, everybody.